Okay, sixth graders, in lesson 5.3, we're going to work on adding and subtracting mixed numbers. Okay, and we're going to have a common multiple. We're going to have to find a common multiple in the denominator, just like you did when you were just adding and subtracting fractions. But let's go through adding first. Let's say that we have a problem like 2 1/4 plus 3 1/2. Okay? When you're adding mixed numbers, you can simply add the whole numbers. Think of these as whole pizzas. And so how many whole pizzas do you have? Five whole pizzas. Okay, and then we can add the fractions. Actually, I want to change the problem a little bit. Let's make this. Okay, so we've also got parts of some pizzas, some fractions of pizzas. We have 3/4. So 1/4 has been eaten by Andrew. And
Yeah!
we have a half also over here that was eaten by Melina. Okay? So we're counting up how much we have left, but we have 4 pieces. So can we just write 4 something? No, you have to have a common multiple, right?
Yeah.
So we have to change halves to fourths. We have to find a common multiple so that the denominators are the same. Okay, so we multiply both numbers in this fraction by the same number and make it into fourths. Now all the pieces are the same size. And this is 2/4. So we have 3/4 plus 2/4, which is 5/4. So we have 5 5/4. Now, can we leave it like this?
No.
Not in a mixed number. Nope. In a mixed number, or if we were answering a question that's like a word problem, we'd have to change it to a number that makes sense to answer the question. So, if we have 5 pieces that are in fourths, we can make another what? We put one of them here, we have a whole nother, come on,
Pizza.
we have another whole pizza.
Pizza.
So now we have, oops, we have 6 whole pizzas, and if we put one of these pieces over here, we still have 1/4. So you have 6 1/4. Okay? Now this is what a diagram might look like. So you understand the problem, and you understand that when you are adding or subtracting fractions, the pieces have to be the same, what?
Denominator.
What does the denominator mean?
The bottom number.
No, the mean, what's the meaning of it? The pieces are the same, who said size? Good, Katie. The pieces have to be the same size. You can't add fourths and halves to count the pieces. You have to cut the half into fourths. We're going to talk about cutting up whole numbers also now. Okay? So when we're subtracting, you have to check and see if you have enough pieces when you're subtracting. Okay? Take an example like this. We have 2 whole pizzas, and we're going to take away 2/3. Now, we don't have any thirds, do we? So we have to cut up one of the wholes into thirds And then we can take 2 of them away. All right, we can't see that very well. I'm going to change that to red. So if we cut this pizza into thirds, now we can take 2 of them away. All right. Then we're left with 1 and 3/3, right? We still have 2 whole pizzas, but one of them is cut up. And now we can take away 2/3 from the 1. So we can take away this, and we're still left with 1/3. So we have 1 and 1/3 left. Now, how do we subtract this? You take one of the wholes and cut it into, right. How do you know to cut it, how do we know to cut it into thirds? Why didn't we cut it into fourths or fifths? Pay attention. Danny?
Because the denominator had a
Yeah, yep, the denominator is in thirds, that's the size of the pieces that we need. So then that's what we should cut the number up, or the whole up into. Why did we write the 3 up on the top and the bottom? Why do you write 3/3? Krista?
Because when we subtract the 3 and 3/3 and then subtract, well, you take 3 and 3/3 and then subtract 2 and 3/3 and you get 1.
But why did we, when we cut up this one, why did I write 3/3?
Because it used to be the whole.
Correct, it used to be the whole. 3/3 is 1 whole. 4/4 is 1 whole. 5/5 is 1 whole. Anytime you have a number written over itself, 4 out of 4, 3 out of 3, 5 out of 5, it equals what? Melina? 1 whole. Yep. So we rewrote this number as 3/3 instead of 1, so that we could take away some of the pieces. Okay? Let's practice another one of these. We're not going to cut it up in thirds. We're going to use a different problem, okay? So write this one down. Work this one out with me. Let's have 10 and 9/20. No, I'm sorry. Let's do this one. 4 1/2 minus 2 and 1/5. 4 1/2 minus 2 and 1/5. Now, first, you have to check to see if you have enough pieces. And so we have to make all of the pieces the same size first. We have to find a common multiple first. So what's a common multiple of 2 and 5? Bella? 10. Notice I'm going to write this underneath so that I have the right amount of room. When you're working out these problems, write the new problem underneath the old one, so you can keep track of what you're doing. Don't do that. Don't throw things around. Okay? So, we would use 2. 5 times 2 equals 10. So multiply both numbers by 2. And multiply both numbers by 5. So we have 5/10 and 2/5. Do we have enough pieces? Do we have enough pieces to take away 2/5, or 2/10, sorry. If you have 5/10, can you take away 2/10?
Yes.
Yeah. So if we check and see if we have enough pieces, then we can subtract these first. Subtract the pieces, which is 3/10. And then we can go back and subtract the whole numbers. 4 minus 2. 2. We didn't have to cut any of them up, did we?
No.
Because we had enough pieces. Okay? Now, that's not always the case. Let's say we have one like this. All right. 7 1/5 minus 4 5/6. Okay. So now, first check to see if we have enough pieces, and we have to make the pieces all the same size. So underneath, what common multiple are we going to use? 30. So change this to 6/30. And this is times 5 to get to 30. So 25/30. Okay. Now, do we have enough pieces? No. Nope, we don't have enough pieces this time. We need to take away 25 pieces, and we only have 6. So we have to cut up a whole. So instead of 7, we're going to have 6. And what fraction are we going to use? How many pieces are we going to cut it up into? 30. How do you write 1 in 30ths? So in other words, if the denominator is 30, then the
Top will be 30.
numerator is 30. Yep. Now, let me rewrite that. So what I'm going to do is I'm going to write that right next to this fraction. I'm going to add 30/30ths to this. So now I have 6 and 30/30ths plus the 6 that we already had, the 6 pieces we already had. So how many total pieces do we have now? Kaden?
36.
36/30ths. And now I can take away 25/30ths. How many is that? Andrew? 36 minus 25. What's 35 minus 25? Okay, so this is 11, isn't it?
Yeah.
11/30ths. Now subtract the holes that you have left. 6 minus 4. Maya?
2.
2. So the answer is 2 and 11/30ths. Is 11/30ths in simplest form? How do you know? How do you know something is in simplest form? Catherine?
Because 11 can't evenly go into 30, and 30 isn't the square of 11.
Okay, good. Okay. 11 doesn't go into 30. And are there any factors of 11? 11 is a prime number. Yep. So if they don't have, if it's a prime number, it doesn't have any other common factors, and this number does not go into the denominator. Okay? Any questions? Okay, so your assignment is on page 147 and 148. Start with number 8. I want you to do 8 through 22 evens. 8 through 22 evens. Page 147, number 8 through number 22 evens.